Thanks everyone for joining the backup and recovery office hours. Today's topic is going to be architect to defend and recover from ransomware attacks. My name is Kelly Smith. I'm one of the product managers at Oracle that works on backup and recovery solutions. Got a couple of my colleagues with me as well. They'll be answering Q&A while I'm presenting. We've got Alex and Marco handling that. So feel free to ask questions as we go along. They'll answer questions, and then we'll do an additional dedicated few minutes at the end to answer questions as well. So let's get started. So first, we have to ask ourselves, why do people care about cybersecurity for the Oracle database? And really, that comes down to the fact that malware and ransomware attacks are increasing. We hear about them pretty regularly, and a lot of them are very newsworthy, as we've all paid attention to the pipeline incident that has occurred this month. They're showing up in the news, and they're causing wide-scale problems. And these problems, obviously, if your company is running Oracle databases that are mission critical for your businesses, these problems cause outages, and outages are costly. They're costly from a monetary perspective, and as we've seen in the news, they're also costly from a reputation perspective. Once your company name is in the news, and that news is not positive, it's around a ransomware attack and an outage that has occurred, that's not a very comfortable place to be in. And that's causing C-levels and boards to demand action and planning around how to protect against cybersecurity. So the session today is going to talk about some of the things that you can do in your current environment, and then some advanced things you can do planning in your infrastructure as you go forward, so you can answer when you're asked, is there a plan for cybersecurity? From a C-level or board member. It's something you've already heard about, something you've thought about, you've picked up some planning actions on, from this presentation, and you can answer authoritatively. Okay, so let's look at changes that you can consider in your environment today. So, nothing that you have to, no new stuff that you have to buy, no new architecture to implement, just best practices and operational procedures for your environment that you use today. So the first thing that we want to talk about is proper access control. And we're going to start at the database level. And yes, the DBAs, of course, need access to the database. They do work in the database every day, solve problems in the database, performance, they implement new functionality. There's all kinds of stuff that the DBA does. So they need, adequate access to the database. But the question you have to start asking yourself is, which DBAs actually need sysdba? There are a lot of roles that are available in the Oracle database, and sysdba is the most powerful. And if compromised, if that account that the DBA is using is compromised, that sysdba account can be very dangerous and cause a lot of problems in a compromised scenario. So limiting the number of people that leverage sysdba is going to make your environment much safer. And then looking at the infrastructure level, does the DBA have access to the OS? Because now you've broadened your exposure, right? You've got access at the application level, at the Oracle application level. Now that same account has access to the OS level. And farther than that, does the DBA have access to the storage? And if you're dealing with SANs, that means that storage subsystem that the DBA could have access to from an administrative perspective could impact lots of different machines, different mission critical machines. If someone can get to an administrative level in your storage, they could delete a lot of data that runs lots of mission critical applications in your environment. So you need to think about how much level of access does the DBA actually need? Do they need complete administrative access to the database? Do they need access to the OS? Do they need access to storage? And should that be a common account? It shouldn't be, right? Your Oracle database account, your OS account, and your storage account should all be separate, to make sure that one compromised account doesn't compromise the entire stack in your infrastructure. And then spreading out to the data center, which databases should everyone have access to, and in which environments? We all have different environments in our infrastructure. There's production, there's test dev, maybe there's some pre-production work. Who should have access to those databases, and in which environments, right? Is it good for a DBA to have access across everything all the time? And are unique accounts being used per database and per environment? Again, we're trying to limit the exposure if one account becomes compromised. You don't want one account to be able to access all the databases in all your environments. So you want to have that account separation. And then if we look at the infrastructure level again, is auditing being done across your infrastructure? And is someone paying attention to that auditing? And you have to look for things like, once you implement unique accounts, are accounts being used in places or attempted to be used in places where they should not be? Because that should start to signal red flags, right? Is the location that the account is being used from, is that suspicious? If your DBAs all sit in one location or in very isolated locations, and now you have attempts to use accounts from locations that are suspicious, it's something you need to pay attention to, because a compromised account, that's the first thing that a malicious attack is going to attempt, is using that account in various locations. So pay attention to the location the account is being used from, and where the account is attempting to, what they're trying to attach to. And finally, are the most important environments separated? And what I mean by separated is, can production easily reach test dev? Can test dev reach production? Isolating these environments ensures that you don't have a compromise that spreads through your infrastructure. And if you think about it, all these separations of accounts, these separations of environments, it's not as easy to move around in your infrastructure now, which I know can be a little bit painful, but that also means that if there's a compromise, the compromise doesn't spread around really easily. Access control, proper access controls with all the gateways that they have to pass through, or the accounts that you have to switch to as you're moving around the infrastructure, is not entirely easy, but that also means that a compromise is not easy. And that's what we're trying to get to, right? Compromises that do not easily expose your entire infrastructure. So now, if we've done all that work, we've locked down access control, we've separated our environments, you're starting to get a good handle on your Oracle databases. Like, everybody is using unique accounts in the right environments. You've limited who has access. You've limited, access between environments. You're starting to head down the right path for just common knowledge lockdowns of the environment. The next thing we want to look at is the backup side, right? Because if you've locked down your production databases, if something did happen, the first thing you're going to consider is, okay, we just need to restore that database from backup because it's been compromised and we don't know what happened. So we need to look at what to do from a backup perspective, because unfortunately, backup sometimes is the last thing we think about, but if in the event of an emergency, that's the first place we go. So let's think about all the different places where backup occurs, and does the DBA is the one creating the backups, right? So they need access to create backups. That's kind of part of their job. But there's a unique privilege in the Oracle database called sysbackup. So is sys backup being used in your environment properly? DBAs, are they falling back to, sys DBA to do backups? Are you being restrictive like you should be and leverage sys backup for those operations? Because sys backup is only designed to do one thing, which is backup and restore. It's not designed to do other database administration work. So it really limits the capabilities of sys backup. And again, you're trying to narrow that access, narrow those capabilities to the appropriate level for the person who's doing the work. So if you're not using sys backup today, definitely take a look at that. That is designed for your backup and recovery job. And that limits your exposure from a backup and recovery perspective. The next question you have to ask yourself is, does a DBA also control backup retention? So if the DBA is using sysdba, and do they control the backup retention? Because that means, I don't know if everybody realizes this, but that means that the DBA can destroy the database and the backup at the same time, or the DBA's account can do that. So that means that if the DBA's account falls into malicious hands, they can destroy the database or manipulate the database and destroy the backups. It gives them way too much control. So you need a strict separation between the DBA and the ability to control backup retention. Because like I said, obviously if the database gets compromised or something happens to the database, your first fallback is to the backup. And if the account that compromised the database can also destroy your backups, that puts you in a really bad situation. So look at account privileges and make sure that account can't control the backup retention, and delete the backups and delete the database. You don't want to have all those things mixed together. And then from a compliance and recovery validation perspective, if the DBA can control backup retention, if they have that amount of privilege, is your retention actually compliant with your corporate policy? Do you have a way to audit that? You want to look across your infrastructure and make sure that all your database backups comply to your corporate policy. As backup and recovery solution product managers, we work with customers all the time, and through our discovery process, sometimes they realize that the backups of the databases that they thought they were taking aren't happening exactly the way they should be happening. So that's something that you need to keep a close eye on, because simple things can happen in the environment that put your backup retention out of compliance, and then you end up in an inconsistent situation across your infrastructure, and then when it's time to recover, that can put you again in a really, really complicated situation. On the backup side, if you're taking backups, they're compliant. How often do you validate? One of the unfortunate situations that we find ourselves in is the databases grow, and nobody gets more backup window as the database grows. That's just not something that happens, right? So as database administrators or corporate, involved in corporate IT, one of the things that typically gets squashed is the validation process, because you're running really short on time from a backup perspective. To add validation into that backup window is very difficult. And your time with the database, your time to put activity load on the database for backups, for validation, as the database grows and becomes more important, that time starts to shrink. People don't give you more time as the database grows and becomes more important. They actually give you less time. So just ensure that you're doing some kind of backup validation regularly. RMAN has lots of validation tools built in. There's an Ask Tom session in the archive. If you look at previous Ask Tom sessions, you'll see that I did a session on, is your backup ready for recovery? So take a look at that. It talks about all these different techniques that you can use for backup validation. So that's in our archive for Ask Tom. And then lastly, always, when was the last time a recovery was performed for the database? You need to be prepared for recovery. And the best way to prepare is to test every once in a while, right? Test a recovery. That way you know the process that's involved to recover the database. When it's time to recover, you don't want that to be an on-the-job learning experience, right? That it's going to extend the amount of time that it takes you to do your recovery. You want to know the process. You want to have had practice with that database recovery, so that when the time comes, it's not a surprise. You know exactly what to do to get the database back up and running. So take the time, do some recovery practices, and make sure that you understand how to perform the recovery, because at the time when you've had a cybersecurity breach and you need to go back and recover data, you don't want that to be a learning experience. You want that to be just a normal run of something that you're familiar with. Okay, so if we've done all the right things there, if you've got your backup retention set, you've got a little bit of role separation between the DBA and their ability to delete backups, you've paid attention to your compliance, you've done your validations and your testing for recovery, your backups are probably in pretty good shape now. So you're ready just with your architecture that you know today. You're prepared to do your recoveries. So now let's take a step farther and look at some advanced technologies. So things that you could implement. So the first thing I'm going to talk about is the zero data loss recovery appliance. Obviously, this is an engineered system that is designed specifically for protecting the Oracle database. It is the world's best Oracle database backup solution because of all the unique things that we can do. And I'll talk about some of those things. And then we'll move just a step farther in the cybersecurity infrastructure. So from a recovery appliance perspective, it protects all the databases on any platform, and it protects them at a transactional blockchain level. So that means that as transactions are occurring on the database, they are protected by the recovery appliance in real time. So if your database was compromised or fail over right now, if it died at this very moment, you would have the very last transaction that came into the database. It's zero data loss. So that's it's very important when you start talking about mission critical databases. You want to be able to recover to the moment that the problem occurred. The next thing that the recovery appliance offers is incremental forever. So I talked about earlier, as the database size grows, because data grows in our environments, that's kind of what happens. That's a reality that we live with. A full repeated backup becomes more and more painful as that database grows. So being able to switch to an incremental forever paradigm means that you don't have to do full backups anymore. Just the changes that have occurred since the last backup get captured by the recovery appliance. And yes, if you're used to leveraging typical and traditional backup technology, incremental forever is a dangerous paradigm, right? Because that means you have to start with the full and apply incrementals until you catch the database up to the last transactions. And that process can be very tedious, can take hours and hours, because you're having to apply incremental after incremental to get up to the current point in time. But what the recovery appliance does behind the scenes is it actually takes the changes that occur each day in these incremental backups, and it builds virtual backups. So that means if you need to recover, every backup now looks like a full. And it makes recovery very simple. So you don't have to worry about recovering the last full and then whatever incrementals have changed, all the incrementals that have been gathered since you're full, everything's a full. So recovery just means you restore the last backup, which is the full, and apply the latest transactional redo logs, the archived redo, which are coming across in real time. So you can really get up to the last point in time for the backup quickly. The recovery appliance also supports a remote replica, so you can put a replica at another site, which means that all the transactions that are captured here, the incremental backups, those all get moved over to the remote replica. So incremental forever here, and real-time redo, incremental forever over to this side, and then the redo gets shipped over here as well. So the remote replica becomes another destination for you to be able to retrieve backups. The recovery appliance also supports Oracle Cloud Storage. So if you need to send data off-site, you can send data off-site to Oracle Cloud Storage. And it also supports tape. So you can do tape out of the recovery appliance. And then the one interesting thing about the recovery appliance, if you're used to traditional backup products store data in a proprietary format, which means that at time of recovery, you have to have the original application to do the recovery. When the recovery appliance creates data that gets sent out to cloud storage or to tape, it's actually a native RMAN format. So if you're pushing data to the Oracle Cloud, for example, and your primary site goes down, you need to do a recovery, you can simply just go to the Oracle Cloud, spin up a database in OCI, connect to your backup storage, and use that data directly without the recovery appliance because it's a native RMAN format. RMAN understands how to read RMAN format. RMAN's built into the database. There you go. You've got the data back while you're trying to figure out how to get your primary site back up and running. It can be running, your databases can be running in the cloud. This is also useful for compliance. If you have a compliance request, you don't necessarily have to drag that data back out of the cloud if it's a couple of years old. Simply spin up the database in the Oracle Cloud, recover from your cloud storage, and now you can easily hand over that database that needs to be used for compliance reasons directly in OCI. So you didn't have to go off and try to figure out how to set up a system and give it space and do all that work. You just bring it up in Oracle Cloud, recover your RMAN backup, and you're ready to go. You hand that system off, and when they're done with it, you can just delete it out of the cloud. You only have to run it for the amount of time that you need your compliance work to take place. We talked about validation earlier. So the recovery appliance has built-in recovery validation. So all that work you would traditionally do with RMAN to do your backup validation, the recovery appliance does that for you automatically, internally, does not put that load back on the Oracle database. So you don't have to worry about that anymore. You don't have to do all those operations and try to figure out when are the best windows to do that work against your Oracle databases, because the recovery appliance does all that work internally on its own. And then finally, the recovery appliance, it bubbles up all of its information. All of its management is done through Enterprise Manager. So now you have a one-stop shop for both database management, backup and recovery management, all in the Enterprise Manager console. You see your real-time protection status of your databases. You see your recoverability for your databases. You see any alerts that have come up around backups. You can set up your backups. You can do space monitoring. There's all, the Enterprise Manager infrastructure has a lot of flexibility and provides a rich interface for you to manage your database environment in one location, from backup to the database itself. It also sees cloud storage and tape, so all that information gets rolled up based on the recovery appliance's activities. So now let's talk about these and why they're important, right? So transactional block changes, that means the latest changes of the database are always protected. They're ready for recovery. You don't have to think to yourself if the database has a problem, either through cybersecurity compromise, some kind of breach. When was the last backup and how much data does that represent that I actually lost because the database got breached and now I need to do a recovery? If your backup was 2 hours ago and your database was breached, that means you lost 2 hours of database activity. With the recovery appliance, you got the last transaction protected on the recovery appliance. Incremental forever, that means small amounts of data, and that reduces your backup time. So that means your databases can be backed up quickly. You don't have to, struggle with trying to protect databases as they get larger and larger. Validation and retention being managed internally means you don't have to reconnect to the Oracle database itself and put load on that database. Validation and retention is being managed internally to the recovery appliance. And then, of course, you've got policy management and auditing. So when I mentioned earlier, do you know if your database backups are complying to your corporate policies? It's really easy to tell in Enterprise Manager. You can run reports that are readily available, and you can send those to people who are asking questions about compliance. And then from an auditing perspective, all the auditing information about when, who made changes on the recovery appliance, when, did a database get added to a protection policy? Did it get removed from a protection policy? All that rolls up into auditing, so you can easily determine what happened and when. And that means you have a good handle on the changes that are occurring in your environment. And then if you do introduce a replica, it's separate, it's isolated, from an access perspective. Its retention and validation is also separate. So that means that you can have a different retention policy on your primary recovery appliance than your replica. Validation is done at every point. So, database backups come into the first recovery appliance are validated. When they leave, they're validated again. And when they arrive at the replica, they're validated all over again. And of course, auditing happens on this recovery appliance just as it happens on this one. So any any changes are audited on both sides, so you see them separately. From a separation of duty perspective, I talked about that earlier. Can the DBA make changes to the backup? The recovery appliance allows for a very strict separation of duty. So the DBA can send backups to the recovery appliance. They can request restores from the recovery appliance. They can't change policies. They can't delete backups. The recovery appliance is managing all of that backup retention through a policy that the DBA can't override. And then the DBA admin doesn't have to have access to the database at all. They're managing the recovery appliance. So there's a separation of duty there. So now the DBA doesn't have access to change the backups. The recovery appliance administrator doesn't have access to change the database. So your backups are separate from your database activity. So you've got a really strong separation of duty now. And then account management can be centralized in Enterprise Manager. So if you need to make account changes and who has access to what, that's a simple process inside of Enterprise Manager to adjust your account privileges or disable an account if something abnormal is happening. So let's just kind of run through a summary of benefits. Databases are protected in real time with the recovery appliance, so you get that zero data loss functionality. You get transactions up to the last moment before a database has an issue. Backups are incremental forever, so they finish faster with fewer resources, and that's the key, right? Fewer resources, less load on the production database. It's not doing as much work. It has more resources to go do the work that you want a database to do and not have to worry about a load from these full backups that have to reoccur on a regular basis. Backups are also validated on a regular basis inside the recovery appliance when they arrive and on a schedule. So you can ensure that there's recoverability of the data. And that validation process, again, does not touch the production database. So those resources get freed up. Retention policy is controlled, eliminating the ability for the DBA to actually delete backups or make changes. And auditing and policy management is centralized and gives you insight and reporting for compliance and any changes that may have occurred in the infrastructure. Okay, so now let's take a look at taking cybersecurity to the next level. A very common method uses this disconnected concept of a cyber vault. And it's called different names, cyber vault, vault. Some people use the word air gap. And the concept is just that you have a secure location that is separate from production, that is disconnected and only connects periodically to get updates. So that means that its exposure to the outside world is very limited because it is connecting on a random basis over to production, gets the latest information, and then disconnects itself again. So if there's a compromise in the production data center, that compromise, because there's no path to the vault, is limited, right? So it gives you a fallback location that's been isolated. So let's look at that architecture in conjunction with what you currently have today. So essentially, you're expanding your current data center with a vault. And what that means is you've got timed access. So this connection occurs on a random basis. No one should be able to set their watch and say, you know what, the vault's going to open today at 1 p.m. If your vault is set up like that, that means that an intruder on the production database side is going to be able to see that as well. Like, oh, vault, there's a connection that just opened up at 1 p.m. Is this going to happen every day? Because that means that I have the capability to just wait and connect in and retrieve data. So this timer should be random. And with the recovery appliance in the mix, it makes things a little bit easier. So, databases are being protected in real time, as I mentioned before. So that means as soon as this vault opens on whatever random time, replication can immediately start and you get the latest changes from your Oracle database backups into the vault. If you were trying to coordinate that, it would be very difficult, right? Because that means that there's knowledge outside of the vault of when the vault is going to open, which again is dangerous information. If the opening is random, the recovery appliance is always ready for the replication. But with traditional products, that means you would either miss the vault opening and you would have unpredictable availability inside the vault, right? Because if your backup ran at, if your backup was scheduled to run at 11 p.m. and your vault opened at 9 p.m., that means you missed your opportunity and now you've got another 24 hours potentially to wait for the vault to open. So you're kind of out of sync. With the recovery appliance, vault opens, bang, all the latest information for the Oracle databases immediately transferred into the vault. So that becomes, a very easily managed replication process. And as I mentioned before, backups are validated independently, and the expiration is handled independently per recovery appliance. And that applies to all the recovery appliances in the environment. So you could have a production recovery appliance, you could have one in a DR location and one in a vault. And validation and expiration is handled independently. And most people, when they're putting the vault together, you don't keep a ton of data in the vault. If you're having to go and fall back to a vault location because there was a compromise or something bad happened, you don't need 30 days worth of data in here. You only need a few days, like 3 to 5 days, that gives you a fallback location. Because really, if you have to take your business back 30 days in the past, that's a bad situation. So typically people only size for 3 to 5 days in the vault. That gives you plenty of fallback location, fallback history to go to if there's a compromise. And you still have your DR location that gives you that rich history of months of recoverability from a DR perspective. From an access perspective, as we talked about zones before, you got your DBAs working out in zone 1. In zone 2, you have your regular production backups. You're just adding another zone, which means a different silo of accounts, different access. You're trying to isolate your vault and only allow a very few number of people in there, and make sure that that data stays safe. Then enterprise managers in the environment, notice that I have it on both sides, and that's because you want the vault to be isolated. You want all your management, all your alerts, all your reporting about the vault to be separate from production. Because if production is compromised, you don't want enterprise manager to be the map that shows the intruder exactly where the vault is located and which machines are involved in the vault. You want a separation there. This enterprise manager should know nothing about what's in the vault. This enterprise manager should know nothing about what's in production. They're isolated from each other. It gives you that extra step of isolation. And then again, auditing is separate, right? And you can really pay close attention to anything that is happening in the vault, because that's very important. You want to make sure that this vault is very secure and you're very aware of the changes that are occurring in the vault. And then watch for intrusion activity that's occurring out in production. Then on the vault side, you'll notice that I also have a gateway on the management side, because you don't want this operator to easily be able to just access the vault at any time. You should have two different people control that, right? One person that controls access to the vault that actually does not have any access in the vault. That means the only thing they can do is open and close the door, right? It's the security guard to your data center. They can open the door and let somebody into the data center. The security guard themselves has no access to any of the machines that are in the data center. So same concept here, right? Somebody opens the door, they have no access to what's on the inside. Another operator has to come in after that door is open, make changes, and then that person closes the door back. And after that happens, you can audit the changes in the vault, because now it's secured again. So you've got your auditing report to fall back to make sure that the changes that said that were supposed to be made occurred and nothing else occurred. TDE encryption. If you're really being serious about security, cybersecurity in your environment and security in general, you need to be considering TDE encryption. That secures your database and ensures that if there was an intrusion and someone obtained data, that they can't use the data against you, right? They've captured data that's encrypted, and that doesn't do them much good. All the processes that I've been talking about that the recovery appliance does, the incremental forever, the real-time backups, the replication, the validations, none of that's impacted by the use of TDE. We can still do all of our recovery appliance work, even with a TDE encrypted database. And then finally, if you do have to recover a database, typically you're gonna recover it to a known good location. And what I mean by that is, if you suspect that there was a compromise in the production data center, you don't want to just spin up a database inside that same compromised environment until the work is done by the forensics experts to determine what happened over here. So bring it up in a known good location. The recovery appliance can easily restore databases to alternate locations. It's a very easy process for it to do. And the recovery appliance allows you to limit the access. So if it's time for recovery, you can create a user on this recovery appliance that only has access to the one individual database that needs to be recovered. So that means you don't have to expose your entire vault to do a recover, right? You just give the single account access to the single database that needs to be recovered. And that data can be retrieved from the vault to a known good location while your forensic experts are out here doing the work. One of the things that I'm going to mention about, database recovery, and I'll provide a link actually in the chat so everyone has it. Just a little bit of cross promotion here. Oracle has this concept of a third Thursday tech talk, and our next yesterday I did one on the cybersecurity architecture, so very similar presentation to this. next month, it's all about database recovery and the speed of recovery. So if you're interested in how to optimize recovery performance, that's next month's topic. So take a look at the third Thursday, because as I mentioned before, being able to practice and understand database recovery is going to be very, very important. So, you know, all the tips and tricks for high performance database recovery, that's next month's topic. So something you want to take a look at. Okay. So just to sum it all up, you've got databases being protected in real time. So as I mentioned before, recovery to the last moment, ready for replication into the vault. Validation is happening independently at every spot. Our man does some validation as it's leaving the database. You know, as that backup data is leaving the database, the recovery appliance is going to do extensive validation when it arrives. When it leaves for replication, it's going to do validation checks on the data going out. The recovery appliance over here is going to do validations on the database backups when they arrive. And then there's scheduled backup validation that occurs on a regular basis. So just because it was validated when it arrived, we don't accept that that's good enough. We're going to continue to do that validation and make sure there's no problem with the data going forward. And also, I talked about replication off to cloud and tape. When the recovery appliance is sending the data off to cloud or tape, it's also going to do another level of validation as it leaves to those other tiers of storage. Access control, of course, is going to be siloed. As I mentioned before, DBAs and recovery appliance admin should be separate, as well as the accounts in the vault, because you don't want to have a single account that has access to everything. That is leaving you open to a lot of compromise. And then you've got scheduled reporting and real-time views of the recoverability of databases and the audits in Enterprise Manager on both sides. Access, make sure that you don't have one person who can open the vault and make changes to the vault. That just means you have an account that can do anything. And then from a security perspective, think about TDE. TDE is something you should be also considering in your environment as you're having these conversations around cybersecurity. And then, of course, as I mentioned before, you don't have to open up the vault to everything if you need to do a recovery. You can be very specific about the database that needs to be recovered and provide individual account access to that database backup. I've got additional resources. We will publish these out on Ask Tom, and that way you have access to them. These are the database roles. You know, I talked earlier about just blindly using sysdba. You need to think about your database roles and who has access to them and make sure they have the right role that matches the work that they're going to be doing. So this talks about database roles. Obviously, the recovery appliance is an engineered system. Our other engineered system that actually runs the database is Exadata. So there's a maximum security architecture paper at this location that you can go and read. There's a recovery appliance product page, and then we've got some technical briefs and webcasts that go into greater detail about the cyber vault architecture itself. So a good read there. Or if you want to listen to it, there's a webcast where I talk through just the specifics of the cyber vault. So like really focusing in on that. If you're not familiar with MAA, definitely take a look at maximum availability architecture. These are the Oracle blueprints for how to provide maximum availability for your Oracle database. You know, we do a lot of work with lots of customers around the world. And these are the blueprints that we provide that give you maximum availability for your database. So there's blogs and the website that covers that. So definitely take a look at that if you're not familiar with MAA. Any final questions or anything that we can answer? Please put it in the Q&A. The other thing that I would encourage you to do is in the Ask Tom, you can submit questions there. You can also submit requests for future topics. So if there's a topic you would like us to cover, be sure to put it into the Ask Tom site, and that's a topic that we'll pick up and talk about during one of the future sessions. So we rely on your feedback to help drive topics for Ask Tom, and we would really appreciate if you would, if there's a topic you're interested in, share it with us, and we'll gather information and share details with you. I don't have any additional questions coming in. Any of the other panelists, was there anything that came up during the presentation that we should dive into here?
No, there were a few questions asked, Kelly, but I think we covered all of them. So if anyone has any follow-up, they can raise their hand or ask any follow-up. We can wait a minute longer in case, but I think we covered all the questions. Yeah, thank you.
All right, thanks, Marco. All right, so if there are no more questions, I'm going to close off today's session. We will post the recording, and I'll post some links on Ask Tom. Thank you so much for joining, and we will see you next month. Have a good day.